from configuring Apache and some of those core modules to really extending Apache into e-commerce, into the types of applications that you see in use on the internet today. So let's start at the beginning. Web 1.0. Okay, you probably have heard about Web 2.0. Okay, 1.0. Web 1.0 basically depended on the web developer to create some beautiful content in HTML and FTP it to the server, and then for people to view this content. And the key statement here is that people were viewing the content. Oftentimes we would have a mail to, where if you want to talk to us, click on the mail to link and then email us, right? And that was Web 2.0 because, 1.0, because it only was a one-way communication, and we had limited set of tools to gather information from users. So as the internet became a more important communication channel, there was a need to, for example, register users for some service. And so at that point, server-side includes came about. Server-side includes being special tags in your file which Apache could locate and replace. For example, the current date and time could be provided with server-side includes. This was not very efficient, okay, because the server-side includes were part of Apache, and so a lot of stars had to line up for this to work correctly. So an upgrade was CGI. Not the kind of CGI with Uncanny Valley, okay, but the CGI as in Common Gateway Interface. Common Gateway Interface allowed us, and I can show you right here where this is located in Apache. Okay, you see the CGI bin right here. CGI bin or Common Gateway Interface allowed us to have Apache execute any program. So if you were on Windows, you could execute notepad.exe, or if you were on Unix, you could execute some shell script that you just wrote. Okay. Now you can probably already see why this approach was soon discontinued, right? Because if you can execute any program, you open yourself up for all kinds of security issues. Also, the other downside of CGIs was that whenever you start a program, you had to fork it on the operating system. And when you do that, there's an overhead in creation of memory for the process, in accessing files and so forth. So if you can run in process or out of process, there's a big difference. Okay, out of process means that Apache is already running maybe 15 processes, and with every new customer who connects to your CGI bin shell script, you're launching yet a new process. And in Linux, this launching of a new process or starting of a new process is called forking. Yeah. Okay. So CGI bin would have been slow and insecure. About the worst combination on the internet, right? Slow and insecure. So I believe previously we looked at CGI bin, and we have print environment variables, test CGI. If we look at this in detail, let me go ahead and go to localhost CGI bin. Maybe my Apache isn't running. Let's see. Oh, I see. I think I changed the port. So here on port 8080, I'm running Apache, and I'll try to run the test CGI script. Whoops. Okay. Oh yeah. Let's stop what I'm doing right here. Okay. So right here we'll say test CGI. All right, and now it's just waiting for me to change the that's not necessary here. So now it's just waiting for me to change mode, and we'll do something very insecure by setting permissions quite open, but now I can execute this script and it's displaying different things, right? And so that's the idea of a CGI script, that you can run it, Apache will execute it. And so sometimes what we've seen with web systems, and we were talking early 2000s, where the software was not written for the web, okay? Software was not written for the web, and we wanted to provide a web interface for that software. Maybe like a registration process. You come to GRCC, we would like to get your first name, last name, and we'll create a username for you. And so that's what CGI was used for. And we would do that with a program maybe called user add on the operating system. And so then the CGI would actually execute that program. Or maybe software like PeopleSoft was used, and they had some kind of a executable program that created users. You could take that program and use the same program inside of the CGI bin directory. Worked great until security and performance got in the way. Most of the time was the performance, because what you found was that after maybe 10 or 15 concurrent users started to run the program, it would respond very, very slowly. So the next level was to take it in process. Instead of executing this custom code as an external process, Apache then would have a new module like mod Perl or mod PHP. And inside of that module, you see, you could run as many pages as you wanted. Low overhead, because you didn't have to launch a new process every time a new user went to execute a file. And security was also increased because suddenly you were not actually running an operating system process separate from Apache. So it was all contained under the Apache identity, and there were only so many things that you could do with PHP. Granted, there's a command called system that allows you to execute, but you have to then specify that command and make the mistake. So a number of languages took this type of an approach. PHP was just one of them, and PHP was developed by Lerdorf. Let's see, PHP. It should be somewhere here. General information. Today, PHP stands for PHP Hypertext Preprocessor, right? It used to stand for Personal Home Pages. When it was created, it stood for Personal Home Pages. Let's see. Maybe best by doing this here. Oh yes. Okay, so here is PHP, and Rasmus Lerdorf was the one who created it. And basically, he created his resume online, and he wanted to track who comes to visit the resume and how many people did. All right, and so he created out of Perl. He created this new language PHP, and PHP took off like wildfire, because it supported syntax that looks like C++ and similar syntax that looks like Java. So you had multiple commands to do the same thing. Echo or print, they do the same thing. Okay, or you could use printf if you came from C background. So it was a weakly typed language, which means that you did not have to define variables at the top of your program. So you can see how weakly typed language may not sound like very secure way of doing things, but in fact it allows you to have very acceptable learning curve. Web developers who are learning PHP were very efficient very quickly. Okay, and so finding these variables that were misspelled, it was not such a big deal. It's when you ran into another server-side language processing like Java with .gsp, Java Server Pages. With Java, you have to first import a bunch of libraries, then you define your variables, then most of the time you end up having maybe object-oriented program where you have to define your classes, define your methods and properties. And so by the time you do that all, you are so tired that you don't even remember why you started writing the program. Now I'm exaggerating, but PHP does help you to write the business logic much quicker than other languages. So if we were to look at maybe a query like most popular programming languages. All right, so there's a few hits. Let's see. All right, so C, Java, and then PHP in the 4th place. But then depending on how you're going to look at it, if you're looking for jobs, apparently PHP does rather well. Hashmead, Google Code, Delicious. Well, in any of these PHP, or in most of these, PHP should score fairly well. Let's look at another one. All right, in this one, PHP is in the 6th place behind Objective-C, which is the iPhone programming language. Let's see, in this one, PHP is in the 4th place. And I guess there's a picture here that I should explain it. All right. Now, out of these languages, though, if you were to ask about which languages are used on the web or which languages are used on the client, you'll find that a lot of Java programming ends up being inside of applications, sometimes on the client itself, but it is sort of a middle tier language, and then those classes can be reused online or somewhere else. So when it comes to web programming languages, PHP scores fairly well. In some areas, and again counting where PHP is most popular or not, whether it is the most popular language or not, it just depends on how you look at it. I've read in the past reviews that show it as the most popular language. Obviously, others have other opinions too. But of course, the benefits are that number one, PHP is portable. Does anybody remember what the word portable means in technology? Yeah. What does it mean?
Take the source code from one and port it over to the language.
Yeah, so you can move the software from one to the other. So let's say that today your organization is running Windows. And so you would like to write your code in technology that perhaps doesn't lock you into the operating system. Because next week, maybe the CIO says, you know what, we just partnered with a new company in automotive industry, and they really would like to do something open source. So now maybe your C# or VB code, you would have to rewrite some of it. So with PHP, you can take your PHP files from the Windows server, put them on the Linux server, put them on Solaris, and they'll work just fine. Okay, so that is a benefit, that it is portable. Yes. Okay, yeah. So there's this other idea of portable, like portable Firefox, that does not require installation. Yeah, yeah. But portable for us would mean that we can take it to multiple systems. It's also portable from the perspective that you can take it from different versions. So the same PHP files can be taken from maybe Windows 2000 to Windows 2008, and as long as the PHP module is running on IIS, okay, you can go ahead and run your PHP files. Okay, so it is not directly related to the operating system. Yeah.
Yeah, I've been hearing these other systems a while ago.
Uh-huh.
C, Java, they all claim that you could compile on one rather than the other, and I think Java would be true.
Yeah, yeah. So with C, I don't know that they claim that, because with C you sort of really compile to the architecture. But with Java, you see, with Java what they've done is when you compile a Java code, you go to intermediate code, and that intermediate code you can move from one to the other, the classes. Okay, so you can move the classes different places. But you still have to have GRE installed on Solaris, GRE on Windows, GRE on Linux.
It would have to be the same brand of Java, I believe, as well.
So you can have by brand. Do you mean like JRE versus JDK or oh, I see. You mean like the Oracle?
Versus Sun.
Right. Okay. Right. So there are different Java versions, yes, or distributions, I might say. There is the open source Java, and I know also of the Oracle, so that's Sun/Oracle, and there might be other ones. The big thing with GREs is that if you develop code for GRE version 1.5, the chances that your application will run perfectly in 1.6 are low. Okay, so it doesn't even matter, going between vendors of GRE. You going from versions also is often not compatible back. So or forward for that matter. But the promise of Java is that if you have the GRE installed on multiple systems, you can move the intermediate code back and forth. So the benefit, of course, is for a vendor. If I'm writing an application like TurboTax, I write one code, and it's ran whatever you're executing on your system. So the promise of PHP is to do that. It's to be portable, but also it is a scripting language by default, right? By default, so by design. And what do you think are the benefits of being a scripting language versus a compiled? What would be the advantage of being scripted? Well, it actually does, because the right. So the issue with a scripting language is that it will be slower than already precompiled code. See, when you have a scripted language and you make a request for the file, something needs to pick up the code, interpret it, compile it, and then execute it. We call them interpreters. That's true. But there's still a process of compilation that takes place. Now, the great thing about Apache is that you can cache, see, this compiled code. So with Apache, for example, you can use something called APC, which is a let's see what it stands for. The alternative PHP cache. And it allows you to basically say, the first time someone touches this PHP page, remember what it was compiled as, cache it, and so next time someone asks for it, it goes out of cache. It speeds up tremendously the system. The drawback is that if you go to make a change in that PHP file, it's cached, so you have to either restart Apache or clear your cache. Okay, but there are methods of speeding up, the PHP sites if there is a need to do that. And some systems, even like Drupal, what they will do is they will include so many PHP files for every request that this kind of caching makes good sense, performance-wise. Okay, so we're talking about various programming languages here. Yeah, so PHP is used, and the reason why PHP became very popular is because of its initial close relationship with MySQL. So MySQL, here's a database that allowed people to store guest books, to store products, to start doing some e-commerce things. And so how do you show data out of MySQL? Well, you can use PHP for free, and it became a stack, and it was called LAMP. Linux, Apache, MySQL, PHP. Or, sounding a little bit less cool, WAMP with Windows, Apache, MySQL, and PHP. This stack in time was renamed multiple times, where you could have Linux, Apache, MySQL, Perl, or Python. So the P, fortunately, stood for multiple things whenever we needed a change. But there are additional languages that do server-side processing. PHP is one. By the way, how can you tell what processing language on the server side is being used by a website? Please. The extension, yeah. So right now, I can look at this browser, and if I say view source, I may have no idea how this code was put together on the fly. It could have been hard-coded in an HTML page and FTP, like in Web 2.1, 1.0. As you look through the source code, you might see certain suggestions, like, hey, there's some PHP files here. But looking in the address bar and seeing that PHP extension is a good lead. Having said that, you can specify on your Apache server that the default handler is going to be PHP, and then you don't have to give any extensions to your files. Or you can say, whenever you see that HTML file, make sure to process it with PHP. Either way. It's not the best practice because developers get confused that way. You know, when you have an HTML file, they sort of expect that nothing that's going to be faster, basically, than a PHP file because nothing parses it.
Yeah, what would happen if you integrate an HTML file?
Not a problem at all, because the only time the module kicks in is when you open a PHP tag. So if the HTML file doesn't have any PHP tags, index.php with just HTML will display just fine, because the module basically skips all the PHP text. I'm sorry, all the HTML tags. Okay, so let's look at some other sites. So maybe let's go to www.grcc.edu/directory, right? And let's look for okay, this page, and I can see that PHP as an extension. Perfect. Let's look at a different page. Let's maybe go to faculty absences and to go to this RSS feed, and notice this extension, .cfm. Anybody knows what this stands for? .cfm. Cold Fusion, right? Used to be, yeah, Macromedia. I think it's Adobe now. Yeah. Previous to that, it was Active something. So it got sold around. It was actually a great product. The problem with Cold Fusion was that it cost a lot of money. They came out with who was the company? Cold Fusion. I bet Wikipedia is going to have some of this history. Cold Fusion here. Rapid application for Jeremy. Alair. That's right, Alair. So in around 95 and a few years after that, there were very few technologies that did web development well. You had all the CGI, which was slow and insecure. But if you wanted to do web development, you could pick up Microsoft tools and create, they called it web classes. Okay, there were DLLs that you hooked into IIS and tried to very, very slow process. So Microsoft sort of was behind on this from the get-go. Or you could start doing Java server pages, but to do that you had to have some infrastructure. You had to have an application server that could read those Java server pages and display them, which at that time, you had some choices with Sun, but it was sort of closed in as well. So Cold Fusion would run on Windows, it would run on Linux, and it cost only $5,000. And a lot of people went for it. That was just the license, right? And so there was a different license if you were an enterprise user, which meant that if you wanted to connect your Cold Fusion server to Oracle, you paid $5,000. If you wanted to connect the same Cold Fusion servers to MySQL, it was like $1,000 only. So basically, they had a really good product. It was fast. It used tags. So I don't know if they have an example of the code, but Cold Fusion code uses tags. So you took a web developer who knows HTML, and all he or she wanted was to add current date from the server, or they wanted maybe to add a form that could send mail automatically. Well, when Cold Fusion was driven by tags, it was easy for them to transfer into this language. So that's Cold Fusion. The other server-side programming elements, .JSPs, Java server pages. Now, I think that JSPs really took off when open source stepped in with Tomcat. See, Tomcat is Apache with a Java engine. So it's still Apache, but now with Java engine. You can start then importing your classes and write JSP pages, and then you execute it with Tomcat, which is another of the Apache Foundation projects. There are some other servers that do Java. There's a Sun application server. There is JBoss that Red Hat now owns, used to be BEA. There's WebLogic as well. But Tomcat is very, very popular today. In fact, Blackboard itself is running on Tomcat. So JSPs. Any other ones you can think of? ASP. All right. So where would I go to see an ASP page? Well, let's see. Let's try that. Microsoft.com. And there it is, right? ASPX. So it used to be just ASP. And then when .NET came along, the X got added, just like in the DOC. There's an X now. So ASP is technology from Microsoft that does server-side processing. So just to be clear, what we're talking about is putting out letter A to the browser. And that letter A is prepared on the server. Because I can see information that you submit, I can modify what I'm going to send you back. Because I know your IP, I can modify what it is. I can see all your cookies on the server. I can send you something else. If I want to, I can send you JavaScript, I can send you Flash animations, I can send you whatever Apache would normally send, which typically is made out of text, right? And I will send you that, and that way, when you enable web server-side processing, so you enable that magic that allows e-commerce. It allows you now to connect to a database or a bank account and do all those things that we know today as web. And this is, at least in my mind, that's the definition of Web 2.0 versus Web 1.0. In Web 2.0, we can do server-side magic, server-side processing. We can connect to multiple sources. So then the web page is customized to the user. They can log in. And they have value. They go just beyond reading something like a newspaper. Okay? And of course, today when we talk about Web 2.0, all kinds of tools are given as examples. Maybe Google homepage with portal type windows, or another Web 2.0 tool. All the applications that Google already has, like Google Earth, documents, Google Docs, and it was just a whole list of different Web 2.0 tools that all involve, what's that? Yeah, that all involves processing and massaging the data on the back end before giving it to you. Okay, so ASPX. Any other ones? Any other ones that you are familiar with? Sometimes you might see where it says .pl, and that stands for Perl. Most of the time, .pl is there when you try to maybe sign up for a service. It means network administrators created a script, and you're accessing through Apache, and then Perl module, you're accessing that script. And there are others. In fact, many companies, including Google, right? They do not advertise what it is that they're using. You see, there's no extensions here, and they do it for multiple reasons. Security probably will be one of them. Then advertising of a technology sort of puts them in a camp, where they want to be friendly to everybody. And you can configure Apache to do that. Basically, whatever the index file is here, you can hide it. And therefore, nobody has to know what file is actually executing any of these searches. Yeah?
Isn't there like some common sense way of knowing what, let's say, Google is using that because it's so fast, like only a few languages would fit that criteria?
So there isn't a way to prove it. You can suspect it.
Not prove it, but I mean, infer it.
Yeah. So
infer it from how fast it is. For example, like maybe JSP would be slow or something.
well, so the speed of those server-side processing tools depend on how many servers are involved. So you can have slow technology, but the moment you put more and more servers into it, it'll actually seem fast. But with Google, it's both. They have enough hardware to cover, a large area. But I'm going to show you here, with the wget tool, you can actually see an HTTP header which can suggest what technology they're using. So with S, let me first go to www.grc.edu, and our server is reporting that it's running Apache 1.3 and it's running PHP 4, right? If we go to Google, right? Oh, well, google.com. They are reporting, let's see, where does it start? They would like to give us some cookies, not P3 policy, and apparently they're GWS, the Google Web Server, all right? If that helps at all. Basically, they developed their own technology. They now have a Google engine that is a server-side processing and development tool that allows you to upload code to Google and then execute it. Right. Okay. So the bottom line is there are many different technologies, but PHP is fairly popular in this stack.
I have a question.
Yes, please.
How does .NET fit into that? Is that usually ported to ASP?
Yes. So .NET, if we were to look here, C# would use .NET, and then Visual Basic would use .NET. What's that? So Java would probably not use .NET. Java would use Java. Yeah. So you can, if you want to, you can mix and match them. So on an operating system, you can have PHP execute Java and then run that. That's fairly common because today you might have many applications on your campus that run multiple systems. So you may have a Java class to reset a password on some system, but it's PHP that's actually running as a wrapper for the rest of it. But yeah, it may be good to do a search on those most popular languages because, and I probably didn't hit just the right website, but PHP usually ranks fairly high, especially in the web development side of it. Okay, so let's just review a little screenshot here. All right, so here is advanced graphic system. All right, and if you are wondering, this is actually a Netscape browser. Let's see. Let's see what I can do here. A Netscape browser, so it just represents a browser, and Web 1.0 would be where we take a line and basically draw between those two. You make a request over HTTP, and I'll go ahead and send you the data. And this would have been Apache, it can be IIS, it can be any other web server. So the great thing about Web 2.0, and where we talk about web server backend processing, is because now this server can also connect to the database. Therefore, the database sends the data to the web server then sends to the browser. And there's a quote that I like by Arthur C. Clarke, that any sufficiently sophisticated technology is indistinguishable from magic. And I call it magic because for me to log in to a website, like my bank's website, and be able to see the transactions I've made and the checks I sent, and to be able to pay someone right from the website, is really amazing. And that's because all the data, right, in the bank is in the database somewhere. And when employees are using the very data, they might be doing it off of another system. Maybe this is what we used to call a fat client, which basically sits at some bank branch, and they are populating the database. But now, through this application stack, I can view part of it in the browser. By the way, this used to be called the thick client because the processing was done actually on the client, and then you were connected to the database. Any downsides that you can see with this kind of application stack? Okay, so security was an issue because I had to have a password to the database. Okay, now, whoa, when you have a password to the database, suddenly you might be able to connect with a different tool than the tool I gave you. That's dangerous.
I guess what I was saying was that the application doesn't know it's really it's their fat client or if it's something else written that.
Yes. So if we can remove all the fat clients, we can simply say, okay, there's only one way to get in, and we can set up a firewall and things like that behind it. Exactly. Yeah. Any other issues with a fat client? And by the way, if you just started watching, a fat client is the application that's running directly against the database. Yep. A same version, right. So if you updated the software, let's say there was a bug, and now you updated it, you had to go to every workstation and apply this update on that workstation. Man, was that a pain to do, because everybody else for some period of time was still running the bug. Okay, so we have this three-tier application. 3 tiers being the database tier, the data tier, the business tier, and the client tier. This was great for multiple reasons. First of all, you could delegate things better. You could say, database administrator is really worried only about this data tier, and he has access to this. He doesn't have to know all the other tiers. Then maybe right here we have a PHP administrator. Okay, we have a PHP administrator who only knows PHP, right? They don't know anything about databases beyond of what they have to know. So here's our PHP, and here's our maybe Oracle or MySQL. Finally, how about this web developer? Right, this web developer who maybe we had to hire out of high school because no one knows web development, right? And so now HTML and JavaScript, all this is being developed by someone who, in comparison of pay, makes nowhere near what the database administrator is making. And they don't even have access to any of the data. All we ask them to do is to create the interfaces. The PHP programmer then connects through PHP functions, connects the database, and we make it run. So this whole idea of model view controller comes out. Anybody familiar with model view controller, MVC? Okay, so let's talk about model view controller. And we start our discussion by trying to solve problems that do not yet exist. All right, is that crazy idea? All right, so MVC, model view controller. Model view controller is part of what's called a design pattern. Let's see if design patterns are actually here. Design pattern, okay? Design pattern. There are a few great books on design patterns. For programmers, design patterns are solutions to problems that do not yet exist. Yes?
Somebody envisions problems.
It's the kind of problem that you are not yet seeing, but it's coming around the mountain, okay? Here's an example. One of the design patterns is model view controller, which means that delegate your web development to someone, keep business logic in different code, and the database separately. Because when it's time to change just the look of the website, you now don't have to engage everybody else. You only do it at one layer, maybe through a cascading styling sheet. So it just resolved a huge problem for you. Someone wants to change the look of their website because it's some kind of anniversary. Great. Well, now I have to get the SQL guy to figure out how to modify this code and blah, blah, blah. No, you just get a web developer who modifies the cascading styling sheet. Another pattern would have to do with pooling. So let's say that you're connecting to the database and you created a single connection. Well, that's fine because you have 5 users on the system daily. Now you have, for some reason, you struck gold and you're creating, you have a product that you're selling everybody wants. You have 5,000 users. Well, now that single connection to the database does not do it. Basically, your database says you're creating too many connections. 1 connection per user, that's too many, and the site is down half of the time. So pooling means create a pool of connections that's reusable, and then as your performance increases, you have an option of increasing the pool, but most of all, those are being reused. Okay? So these design patterns, and there are many of them, are solutions to problems that you will have, but at the moment you're not yet visualizing it. It's not close enough that you're recognizing it. But they are design patterns, design solutions for coding. So MVC is one of them, and in MVC we have view. So this is where the customer is actually connecting, the customer is interacting, it's the interface. This interface can be written in HTML, but this interface could be written in through a PDF. You can have a contact form through PDF, and maybe there's a need for it. Or maybe the interface comes in Flash. Okay? Now we're going to HTML5. Well, let's rewrite all the interfaces. And as long as those interfaces are separate from the business logic, you're just fine. So then you have business logic, and then you have the data at the bottom. And so all kinds of ways of doing that. Okay, so that's what we come up with. We can separate, delegate the work. Therefore, we can keep the business logic separate from the actual design, and it makes our coding more efficient, more secure. We can update everybody with a single change of code, and that's the great thing. So here's the other benefit of having scripting versus compiled. Let's say that there's an error on the website, and it says internal server error. Okay, that's about the worst error you can get, because all it means is that the software crashed and it doesn't tell you anything else. Internal server error. So if this is a compiled piece of software, you have nowhere else to look. Maybe there are some log files you want to take a peek at, but you're done. Whereas with PHP, you can start looking at the code. You can say exit at some point. Let's see if the code executes up to this point. And you can narrow your scope. So now you see the web administrator or the engineer that's running the website, even though they don't know how to code the thing from A to Z, okay, they can start poking around and try to figure out where the problem is. When you have compiled software, you call the vendor and you ask, how much do I pay you to get this fixed? Yeah. So that's why the scripting languages took off so quickly, because everybody was a little bit in control of what it was that was being executed. Okay, so that's the connectivity. And now on the client side, you have multiple technologies. What are some of the technologies that you can execute on the browser itself? JavaScript, yes. Because if you set this page on the desktop and you double click on it, it's running from your C drive from the desktop. JavaScript will run. The browser reads in the JavaScript and renders it, processes it. Okay, what other technologies in addition to JavaScript? Oh yeah, HTML 4 and 5. Any other technologies? XML, sure. So XML is a way to even write web pages. Most often XML is used as a transport language. So if I'm going to send you a list of products every day, instead of sending them in a text file, I can put them in XML, which is self-referencing. This part is the product name, this part is the description, this is the price. If I'm missing price for one of the records, it's not a big deal, because the parser will notice that that element is just missing. Whereas when you have tab delimited files, it just goes really badly if something is missing or there are wrong tabs. So XML, yes. Any other ones? Flash. So Flash, see, is installed on the browser, and it's a plugin. The server sends out some binary file that looks to it like an image or a video, right? It doesn't matter what it is. It's sent by the browser, executed, by the server, executed on the browser itself. Compatibility issues at times, creep in. But Flash for years has been a great tool to provide animations, to provide intellectual property management around books and other files. All right, so Flash. Any other ones? Adobe. So PDF files. Yep. So you could send out PDF files, and again, on the server end, it looks like it's a binary file, and you just send it over. Most of server-side languages, like PHP, allow you to create a PDF file on the fly. Okay. I added a new assignment to the 241 class over the spring break, where you can from the database, you draw the data, and you create on the fly a PDF file. There's a library that allows you to just go ahead and generate one. And it's great because if you try to print, right, PDF files are fairly reliable in how they come out. It can include pictures and other things. And the other assignment part of it was creating images on the fly. So you can go to the database, you can grab some meaningful data and embed it right onto an image. Do a sort of text-to-image conversion. Maybe you've seen those on bank websites where it says, hey, 30-year loan, 4.0%, right? And it's right on the image. See, there isn't a developer on the back end sort of manipulating the images as those change. It all is fed from the database and just created on the fly. So the data comes from the database. PHP puts together the image or PDF. Yeah, two different things. Yeah. Of course, you could embed an image into a PDF if you wanted to do that. You can create the image through PHP and then embed it into a PDF. Yeah. And the way you do this with these languages is you still have something called index.php, but the very first line in that file is going to be with a header function. And you say that the header of it is no longer, the output of this file is no longer text/HTML, but now it is a picture image, or it's a binary file, or it's a PDF file. So then the browser automatically, as it reads it in, it knows to render it as an image or as a PDF. Okay, so that's how we communicate back and forth. On the server side, we can have Cold Fusion, Java Server Pages, different technologies that we discussed. On the database server, we pretty much have one language, right? And that's SQL, right? So that's been standardized by ANSI. The thank you. It's getting late. Yes, yes. Kelly, did you say?
I was just wanting to know if fonts are a good database, or is it actually
Like BitTorrent, you mean? So those are, I believe, peer-to-peer connections, which basically means that you have multiple workstations connected with one another, and when you say, I want to download this file, it will go to whatever workstation advertises this file and grab it from that instead of any servers, which is why it's so difficult for law enforcement to track illegal downloads, because those downloads exist on personal computers of people, and the moment you shut down one, another one pops out somewhere else. Okay, so this takes us back to PHP, and there is a nice startup just in documentation. Let's see, under English there's going to be a manual and a get started simple tutorial. There it is. And part of this simple tutorial, we learned that hey, to run PHP, it's really great to have maybe a database along, your first PHP page would be a little bit of HTML, and then a single line of PHP, and some more HTML. So the way the module for Apache works is it will skip all code that is not PHP and simply spit it out directly to the browser. Then it stops and processes through interpreter whatever the PHP says. And so the result is that on the browser, echo means print or output, and go ahead and output it this way. So this page looks no different at the client end if it's hard-coded into HTML or if it's on the fly put together. All right, and so that's where the security is gained, and because it's a module, we also have gains in performance. It does not have to be executable. In CGI, it had to be executable. It had to be dangerous. Now the PHP files just have to be readable, no longer executable. Yeah, so it's a nice nice entrance, and we will use this line right here, a single line of PHP, and you will see hundreds of lines of output because it'll give you a nice walkthrough what PHP is all about. Okay, so what I'm going to do next is, without actually running it, I will walk through the steps in our lab. And so we are going to start our compiling of Apache. We'll start compiling Apache just like we did any other times. Okay, we're going to download the source code. Then we're going to update the operating system. You see, PHP is complicated enough. It has some requirements or dependencies. So the first line here, apt-get update, is going to take our Knoppix Debian. It's going to download all the current information from repositories, and then we're going to get this library called Flex. It's a dependency for PHP. And then notice that now we will be inside of the PHP source files, not the Apache source files. Apache was already compiled and it's ready. We are going to be under the PHP source files, and we will configure PHP with this key parameter. We're saying go ahead and use Apache, which is, by the way, installed in this location. And then we will include MySQL, and we'll specify where PHP will be installed. APXS is a special extension for Apache. It's called the Apache Extension Tool. And it's an executable program which knows everything about your Apache installation. It's under the bin directory in Apache. And it allows us to create additional modules for Apache. You see, so that's why when we end up configuring and installing PHP, we're going to use this tool to do this with. That way, it knows everything there is to know about our Apache system. Unlike previous of our labs, where we compiled modules right inside of Apache, so the HTTPD had all the modules we needed, like proxy, like status. Now we will compile Apache as an external module. The benefit is that next time I need to upgrade Apache, I just replace that module and I don't touch, next time I have to upgrade PHP, I just replace that module and I don't touch Apache at all, because Apache is now an external module. Technically, when Apache starts, it takes it longer to do it with those external modules. But then once it's running, there's no difference in performance. So we can sacrifice a little bit of the startup time, microseconds of it, with the flexibility that you have when you have an external module and you can actually manage it externally. So we will say make install, and at that point we are ready to add this key config inside of our Apache config file. This simply links extensions of files with the interpreter that's going to be used. So if you would like .html to have PHP meaning, you go ahead and add .html to it. Or you can add .cfml or .gsp. This is where you decide what extensions will have PHP enabled. Finally, we start Apache, and then we'll create a new page inside of Apache, and hopefully it'll work. It'll work. After that, some of our other labs are going to be working with OS Commerce. We'll install PHP, and then we'll put OS Commerce on top of it to actually have. We're not going to write PHP code. Who wants to learn that? There are other classes that teach that. So we will just borrow that code from OS Commerce, pop it in, and then we can add SSL to it, and so forth. So that's how we'll build in the future. Okay,